You're listening to the N2K Space Network.
Hey everybody, Dave here. Have you ever wondered where your personal information is lurking online? Like many of you, I was concerned about my data being sold by data brokers. So I decided to try Delete Me. I have to say, Delete Me is a game changer. Within days of signing up, they started removing my personal information from hundreds of data brokers. I finally have peace of mind knowing my data privacy is protected. Delete Me's team does all the work for you with detailed reports, so you know exactly what's been done. Take control of your data and keep your private life private by signing up for Delete Me. Now at a special discount for our listeners. Today, get 20% off your Delete Me plan when you go to joindeleteme.com/N2K and use promo code N2K at checkout. The only way to get 20% off is to go to joindeleteme.com/N2K and enter code N2K at checkout. That's joindeleteme.com/N2K, code N2K.
In the world of testing and simulation, there's this term digital twin that's often used, but there happens to be a new take on that term called a virtual twin that we hear kicking around. So how does a digital twin differ from a virtual twin? Is this just marketing spiel and spin, or is there a real difference? And what is the application and purpose of a virtual twin? Well, let's find out in today's episode. Welcome to T-Minus Deep Space from N2K Networks. I'm Maria Varmazes. Our guest today is Jason Roberson, and he is an industry value expert in aerospace and defense at Dassault Systèmes. And Jason works with both digital and virtual twins, and he helped me understand the application of virtual twins across the space industry and beyond. And he started our conversation by walking me through his path into his current role.
My career background was in the U.S. Air Force. I was in the space program, primarily in the space program, but I did some other command and control and other special activities. And if somebody wants to look at my LinkedIn profile, you can kind of get a summary there. But 25 years dealing with the space environment. So I've seen things change a bit. When I retired from the U.S. Air Force in 21, I consulted with startups for a while. So I got to see and meet, interact with a lot of space innovators. So it was really cool to see that what they're bringing to market, what they're developing. And then an opportunity came up with Dassault Systèmes. They were looking with somebody to work with space strategy. And Dassault Systèmes has been has really a 40-year legacy of innovation in the aerospace industry, and deploying virtual twin experiences across design, production, and operations in the aerospace industry. So I saw a lot of potential for that because, once you field a space system, you don't bring it back into the hangar, well, not yet at least, to do things. So having a virtual, a science-based, actual, real virtual twin of your product before you go into space is really a game changer, and the capabilities that are there and can be brought to the market. I was excited about that. I'm still excited about it, and work on that every day. I'm on the global team, but I primarily focus on the Americas and what we're doing in space, mostly in the U.S. and Canada, but also in Central and South America as well.
That's super cool. Well, Jason, you've had a fascinating career path, and I love learning about the different paths people take because I think it's just a really interesting view into how people get to do these really fascinating things in the space industry. So thank you for walking me through that. It's really cool. You mentioned the virtual twins, and that's a phrase that I've heard a little bit about in some other interviews that I've done, and I have to admit, I'd love to get a better sense of what we mean by virtual twins. So can we just start with a really basic, help me understand what we mean by virtual twins?
Yeah, absolutely. And you've probably heard of digital twins. That seems to be, I've heard that mentioned a lot. Well, digital twins, you've got a digital mock-up of your product. We'll call it a satellite. It could be a subsystem. It could be a rocket, fill in the blank on what you want to imagine there. But a virtual twin then takes this digital twin into a science-based virtual environment in which that digital twin will live and operate and interact with other things, other satellites, other ground stations, the electromagnetic environment. So in this virtual twin experience, you bring all those virtual all those digital twins together into a virtual environment. So it's connected, it's model-based, very dynamic, and then you can reuse it as you run simulations. You can go through potential scenarios that can be rapidly explored, predict future behavior, and then come up with precise solutions to be created for your products and your processes.
That sounds, it sounds amazing. And especially I was curious how it sort of works in with simulations, because I think especially in really Gen Pop, we might think of these things all being sort of mashed up in the same, but they're not. As you said, there's a really interesting distinction between what comes in where, and the fact that the systems sort of, they feed into each other, and that the virtual twins get data from, that they pull in data as things are being run. That is really fascinating to me that's even possible.
Yeah, it's definitely continuously evolving and continuously improving. But there's so much data being generated today, and that applies to space systems and space processes and even geospatial analytic data. So all those feed into other processes. As you know, space touches more than just space. So space touches agriculture, it touches environmental things, it touches defense. There's so many aspects there, and so really working in space, you work across a lot of industries, and there's virtual twin capabilities or virtual twin opportunities in all those industries as well. So you can really have a system of systems of virtual twins to really improve efficiencies and products and really help your organization out.
Yeah, when we're talking about systems of systems, my brain goes, that could also maybe be really complex or sound extremely maybe complex or intimidating. To me, my understanding of this technology is that it's getting really widely adopted. It's really changing a lot in the last few years. Has that also changed made things easier to understand? Has the barrier to entry sort of fallen a little bit on that?
Well, when we could talk about the virtual twin piece, but I think what's we should probably look at is the barrier entry to space and how the virtual twin helps there. So I don't have to tell you that space is hard, but in the last 10 years,
tattoo it on my forehead.
Yeah. So in the last 10 years, we've seen the barrier to entry for launch has reduced a lot, with about a 10-time reduction in the cost to launch. So it opens up the end for a lot more people to enter the market, but then you still have the traditional challenges of technology and such. But one of the interesting pieces here is that last year, about 90% of launches were commercial. And if we go back 10 or definitely 20 years ago, you'd see the flip side of that, where most of them would be government, because it took really the treasure of a nation to get to space. But now it's a commercial market. Now, the other barriers to entry are your capital requirements, of course. You got to have expertise. Then there's navigating regulation, that's international regulation, and your host nation's regulation. And then, of course, there's competition. As the barrier to just physically get to space expanded, well, you get a lot more people with their innovation taking it into space. So it's an exciting time to be working in this industry. But the virtual twin can create, from your product to your process to your next generation, it can really fuel your innovation and improve your competition in the market.
Yeah. Can you paint a picture for me of how things have progressed over the last few years, given how fascinating this technology is? Where has it come from, and where has it landed so far?
Well, it started with 3D mock-ups, and there's still a lot of 2D CAD in play in the world, but there's 3D mock-ups, then creating completely digital products. Like you create your product basically on your laptop, and here it is before you bring it in front of your investors. You bring it to the factory. Speaking of the factory, we even have virtual twins of the factory, so you can design your factory, its processes and its outputs before you even break ground, to say, here's what this is going to look like, and here's how it's going to come together to build product X or Y and Z. We talked about in the past how expensive it was and limited it was, but in the past you'd build whole factories to build one constellation. And then you'd maybe adjust that factory to build a different constellation. Well, now you can build a factory to build, almost for mass production of satellites instead of bespoke satellites. We're seeing more. I mean, look at Starlink. They're churning those out, but others are coming into the market too with more mass production of satellites instead of just bespoke one-offs. Those are still there, of course, but being able to build those virtually, build how you build those virtually, and then have a right first-time product before it comes into the real world is really a game changer, especially when you look at virtual prototyping and testing of your product. If you test that virtually, especially the electromagnetic simulation, you can see how that's going to behave before you build the product. And one of the areas I've heard mentioned in many different forums, spaceports and launch infrastructure, the need for that to expand and grow. So I think there's a real opportunity for virtual twins to enhance our spaceport and launch infrastructure to improve efficiency or see where we can expand, see what our surge capabilities are, et cetera. So, and then in-space logistics is an emerging area, the area of ISAM and others. So I think virtual twins, there's a lot of game to bring to those areas as well.
ISAM too, such a fascinating area that has always sounded very sci-fi to me, but it's real. And, it's amazing what people are already capable of doing, and where that whole field is going is just amazing. I could absolutely see where virtual twins could come in there. I mean, especially since it's not going to be exactly easy to see what would happen when you're out there servicing a satellite. Not a whole lot of ability to test that on the ground. So that makes a lot of sense. Do you have any proof points or favorite examples of how the technology is being used today, and maybe how efficiencies have been gained?
We have a lot of customer stories across our 11 industries. And there's a few that are specifically for space in our aerospace and defense industry. There's stories from Anywaves, Interstellar Lab, D-Orbit, and NASA. And these stories, you can see where they're using portions of our solutions all the way up to the full 3D experience platform, where they virtually built their product before they brought it into the real world, and the advantages that they got from that. We're consistently evolving the capabilities as well. We invest a lot into our research and development to continue to improve products and processes and solutions for our clients.
We'll be right back.
And now, a word from our sponsor, Cortex. Security teams face a barrage of more security tools create more complexity. More devices need protection. More specialized focus areas create more silos. The security landscape is changing fast. How can security operations transform to meet current threats? Cortex by Palo Alto Networks consolidates SecOps tools into an integrated platform and helps organizations stop threats at scale with AI, automation, and analytics. Learn more at paloaltonetworks.com/Cortex. The IT world used to be simpler. You only had to secure and manage environments that you controlled. Then came new technologies and new ways to work. Now, employees, apps, and networks are everywhere. This means poor visibility, security gaps, and added risk. That's why Cloudflare created the first-ever connectivity cloud. Visit cloudflare.com to protect your business everywhere you do business.
I feel like I have to ask the obligatory question I ask in every interview nowadays about, where do you see AI fitting in with this? So I feel like I should just have a cutout version of me asking that, because it comes up all the time. Is AI even, is that something that you all are interested in terms of how it interfaces with the product? Is that just hype, or is there something real there that could come into play?
I think it has to. I think with what AI is bringing to all markets, you have to be integrating it into the capabilities. You can look at science fiction stories where you have AI co-pilots of space planes, etc. But I think it's really only limited by our imagination. So as we want to bring this innovation into the real world, it's going to be paired with AI in many ways. And of course, with virtual twins, you can automate intensive processes that are essential and have AI handle that, like space traffic management. That's going to eventually be a challenge that has to be looked at, and a lot of on-the-go activity has to be done in that environment. There's also predictive maintenance. Whenever we fly an aircraft and bring it back, we can get hands-on and do the preventative maintenance. But the data we're generating and AI being able to look at the data in a different way and a broader view of the data than we can help with predictive maintenance on our space systems, that we know when failures might occur, what we could do in a contingency, say that you lose part of your constellation or you need to surge to replace part of your constellation. That's where a virtual twin of your spaceport and these connected virtual twins could come into play, and the AI could help you generate those solutions. So I think AI is going to be integrated into a lot of space activities, from design, simulation, testing, as I mentioned, the spaceports, and then constellation operations as well. And I know there's a lot of great innovators out there working on AI specifically for the space industry, and even specifically for areas of space we just mentioned.
Yeah. It is always fascinating to hear the potential where AI could come in, and usually when I ask this question, I get an answer that's like, I never would have thought of that, because it is, as you said, it feels like the possibilities are truly endless, and to see where maybe it could fit in and really augment things, which is so fascinating. I say that word a lot, but it's...
Well, one of the areas I think specifically, to try to give it a specific rather than just broad examples, is, we have virtual twins of factories right now. We can do a virtual twin of a factory, and it generates data and shows you where you can improve your efficiencies. Well, these commercial space stations that are coming into orbit, from different players, they're essentially shop floors and laboratories in space. So we could create a virtual twin of those and their processes on board to say, hey, you're going to make pharmaceuticals, here's your production rates, here's your processes, or whether it's, fiber optics, or whether it's materials for in space. If you're going to ship up raw material and assemble it in space, here's some simulations we can do and create. And I think AI would definitely have a role there with generative design for these systems. Yeah.
Yeah, I could absolutely see that. I think the word fascinating needs to get retired, but it really, I keep saying it just really is so neat.
It's a good one, yeah.
I can't help it. It's just like, wow.
Well, it's good enough for Spock, so it's got a place in space.
Yeah, I was in no small part influenced by Spock, so that's I'm even wearing blue. What can I say? So outside of AI, though, because AI is, as I said, it's my obligatory question because everybody wants to know, and I can't help but ask. There is other technology development outside of AI, of course. So where are you all taking virtual twinning outside of AI? Like where should we be expecting to see it go next?
Well, that's a good question. I focus mostly on the space segment, but based on my background, I help with defense as well. So I think we can see virtual twins of not just so much products. So a virtual twin of a satellite, or a virtual twin of your factory, or a virtual twin of your rocket. We can create a virtual twin to show how the vibroacoustic environment of launch impacts your satellite and your rocket body, and then those things. But I think the virtual twin of processes is going to be where we see evolution, so that whenever you can do space traffic management or the many complicated aspects of ISAM missions, space situational awareness even. The U.S. Air Force invested, I guess it was last year or the year before, some exploratory contracts, I'll call them, for digital twins of space. And that's to get situational awareness in space and to predict behaviors. So we're going to see virtual twins of that. So a digital twin, I'd say, is the first step. Let's get a digital twin of a piece of low Earth orbit, for example, and then let's broaden that out and have a virtual twin of, okay, here's our launch cadence and where things are coming in. Here's our satellite traffic. Here's our electromagnetic environment. Here's where humans are flying through that area. So as you connect all these, if you had a virtual twin of your space environment, it would be very
like debris,
powerful.
For example, right?
Oh yeah, debris as well, and that's a challenging area as well. And sustainability is one of the things that Dassault Systems focuses on across all our industries. And I think I'm glad to see a lot of attention coming into space sustainability, not just sustainable ways to get to space and help us on Earth. That's obviously the priority is space for Earth. But sustainability of the space environment. There was a recent agreement about low Earth orbit, getting things out of there after 5 years. There's been investment by the Space Force and SpaceWorks for debris removal missions. So I'm glad to see that happening. And I think AI, you really brought up a good point there, that space debris and that variable in the whole factors of space, that AI could help a lot there. And a virtual twin of all these processes is very
I could totally see
helpful.
that. Yeah, because modeling seems to be a thing that comes up as we can only figure out so much. So I'm just imagining a virtual twin of a certain swathe of orbit and figuring out what's in there and modeling where things are going. I mean, that would be, wow, okay. That would be so neat.
We'll eventually get there, and in a few generations, they'll be like, "Why was this hard for those guys?" So it's, but
hindsight,
Yeah, exactly.
Yeah, but for now,
a few hundred years from now, it'll be a piece of cake.
Yeah, we're not in the Star Trek future just yet, but one day. Yeah, that would be. Seriously though, I mean, to be able to unlock that capability and make different orbits safer for ongoing activities, and especially for any kind of human activity going on out there, keeping the crew safe is paramount. So, Jason, you've blown my mind in the best possible way with all these really cool capabilities that y'all are working on, and I'm just like, wow. I want to make sure I give you the floor if there's anything that you wanted to mention that I didn't ask about, because I'm sure I missed something really cool that you wanted to tell me that I didn't know about. So,
well, I think that 100 years ago we saw the golden age of flight, and I think today we are entering, if not already in, the golden age of commercial space. Everywhere, all the events I go to, and I listen to guests on your podcasts that are bringing great innovation into the market. And I think it's an exciting time to be in the space industry, and we're going to see more benefits come in from digitalization and model-based approaches in space, and to only further enhance what we can do and how we can really improve life on Earth by optimizing products and processes for the real world by leveraging the virtual world. And one of the things I would like to highlight that Dassault Systems is a very big supporter of startups as well. There's a SolidWorks startup offer as well as a 3D Experience startup offer. So those innovators that are out there, they can contact me or just do a search for those terms, and they'll find where they can apply. And we also have a 3D Experience Lab, which is an incubator that we support development of different products and processes. And there's one company that was pretty cool to see in a recent incubator that's in Europe that's developing refueling. And I know there's companies in America doing that as well. But so yeah, there's opportunity for startups. And I think startups have a big advantage because they're born digital. They're not going through we'll call it growing pains. I mean, some companies are just killing it with their digitalization and going beyond just, hey, it's an Excel spreadsheet, we're digital. It's like, no, we're actually doing models and virtual and digital twins. So I think there's call it the startups. They have an advantage there of starting digital, being born digital. But yeah, a little plug for those areas.
It's the language they speak.
Yeah.
Truly, yeah. Although many a good company has been born and functioned out of an Excel spreadsheet. So, but still, point well taken.
Absolutely. Yeah. I mean, everybody uses Excel. It's just a model versus rows and columns. It's a very different capability.
Absolutely. Well, Jason, thank you so much for this awesome conversation. It's been a joy speaking with you, and I've learned so much from you today, which, as I often say, it's what this job is all about for me. So thank you so much for sharing your expertise with me. I really appreciate it.
Well, thanks for hosting me. It was a pleasure, and I look forward to meeting you in person at a future event where we both show up.
That's it for T-Minus Deep Space, brought to you by N2K Cyberwire. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures we deliver the information that keeps you a step ahead in the rapidly changing space industry. T-Minus Deep Space is produced by Alice Carruth. Our associate producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karpf. Simone Petrella is our president. Peter Kilpie is our publisher. And I am your host, Maria Varmazis. Thanks for listening. We'll see you next time.